Perfect squares come from taking a whole number like 3 and squaring it. So 9 is a perfect square because 3 times 3 is 9. These are all examples of perfect squares. This term 2y, whole number with a variable squared, that's a perfect square. And notice that that's the whole thing squared, not just the y squared. So these are examples of perfect squares. When you take binomials, you can expand your perfect squares by doing the same thing that we did before, by getting the product of two binomials, a plus b times a plus b. We do exactly the same as we had done before, first, outer, inner, last, and we combine our like terms, remembering that a and b, ab and ba are the same thing. They're just because we multiply in any order. That's essentially two ab's. We do the same thing when we have a minus sign, when we have a negative in there. We lay them both out, we multiply them by the first, outer, inner, last, and then we get our expanded perfect squares. You can also get the difference of perfect squares, the DOPS. And that's when you end up multiplying a binomial by its conjugate or its opposite sign. So if you had x plus 3, its conjugate would be x minus 3. And it's pretty cool how that works out. When you find the difference of perfect squares, you will get a squared first, and then you'll get a negative, because one of them is positive, one of them, it doesn't matter if it was a minus b first or last. You'd find that these two, remembering that ab is the same as ba, they actually cancel each other out. And that's what will happen in the difference in perfect squares. So you'll find that you'll get the firsts in the end. You have to work it out and prove it. And the lasts, and because it's the difference of perfect squares, it's going to be a difference. Okay? And again, it can be negative first and positive second. It doesn't matter. It doesn't matter. So let's have a look. Expand each of the following. So x minus 2 squared is to say the same as x minus 2 times x minus 2, because that whole thing in brackets is squared. So I'm going to do my firsts, x squared. And am I going to plus or am I going to minus? And what am I going to do next? X times negative 2, so that's minus 2x's. And then I'm going to have negative 2 times x, so minus 2 more x's. Now don't be fooled into thinking they cancel each other out. And negative 2 times negative 2 gives us positive 4. Now we keep our x squared. Negative 2 minus 2x is the same as saying negative 2x plus negative 2x. So we end up with negative 4x's, and we'll keep our plus 4, and that puppy is done burger. 2x plus 2, the whole thing in brackets squared, is the same as plus 3. Did I say 2? Times 2x plus 3. Same dealio. 2x's times 2x's is 4x squared. 2x's times 3 is positive 6x. 3 times 2x plus 6x's, and then 3 times 3 is plus 9, which gives us the end result, 4x squared plus 6 is 12x's plus 9. Couldn't be simpler. Could it? I don't know. So now we have that conjugate I'm talking about. I've got x plus 2 multiplied by its conjugate. So we're going to find, that this is very exciting. We're going to do the same thing, and we're going to find out, I'll bet you big bucks that it's going to be x squared minus 4, because it's going to end up being this one and the last one. But let's do it in order. X times x is x squared. X times negative 2 is minus 2x. Okay, doing good so far. And then over here, 2 times x is plus 2x. Uh-oh, there it is. And then 2 times 2 is negative 2, rather, because that's a negative 2. Negative, what is it, 4? It's 4. And so here, negative 2x plus 2x cancels out, and we get x squared minus 4, exactly as I said. What do you think this one's going to be? Have a think for a second. What do you think it's going to end up being? Remember, you got to square these puppies as well. All right, let's do it. So we have 3x's, take away 2y's, up against the conjugate of 3x's plus 2y's. That's what makes them conjugates. Negative e, positive e. Let's do it. So 3x's times 3x's, 3 times 3 is 9, times x is x squared, and then 3x's plus 3x's plus 2y's is positive 6xy. 3 times 2 times x times y. Now we've got negative 2y times 3x, so that's going to be minus 6. We could put yx. Let's do it, because that's the order they came in. Is that the same as xy? Yes, it is. And then finally we have negative 2y times, positive 2y. So negative, positive makes a negative. Negative 4y squared, isn't it? So these guys are the same, and I wrote them in the different order on purpose, but the truth is negative yx is negative xy. So they're gone burger, and so our answer is the first two minus the last two. There you go.